Cambridge and so on. And then it gives you an initial condition. Sometimes they say x of 1 is this. And they go f of x is this, whatever it is. Or they go x plus something or minus is something else. Well, they give you the initial condition, 1 again, and the function. And then they want you to repeatedly, as well as successfully, continually put in that, that initial initial value to produce another value, which would be x of 2, x of 3, x of 4. Every time you put in a value, you get, you have an x, you put something in, you get an f of x. Let's call it a y. You take that with that value, whatever it is, you put it back into the original equation, and then you do it again and again and again, continuously. It's called looping, okay? And if you're in computers and so on, this loop happens all the time. So for example, if you wanted to write something like it, when I was a young person a long time ago, it was BASIC. Or Fortran, even in the movie, she's just learning about Fortran. Fortran was the thing in the movie with Dorothy, okay? That was the computer engineer. And what happens is if you put certain steps in, it will just keep on going back to the initial condition, okay? Go ahead.
In my computer science class, we did for loops and while loops. So
while loops, yeah, while loops. So it can actually branch out and go into another function and so on. Okay? So that's what this is actually going on. I just wrote this because I felt like it. Okay, I was getting into it. All right, you know how I get, all right? So the biggest thing is you get start x1, you get a y. And then you got that initial value. You take that new guy, you plug it back in, you get another value. You take that other new guy, etc., etc., etc. And then it wants you to approximate and find out whatever's going on and so on. Okay? Now, why do we do this? Why do we care and everything else? Well, it got Buzz Aldrin to land on the back safely because they didn't have the mathematics associated with it. And in the 17th century, Euler came up with that method. I'll show you, this one guy does this little stepwise method. It shows the beginning of what's called numerical analysis, okay? And Newton talked about it later, which was infinitesimals, okay? Small little gradients associated with the slope, all right? So there's Newton's method, which I'll do that. When I was a kid, I was doing it all the time. And then Euler's method, which was popularized by the movie, okay? So let's take a look at, well, the Cambridge, right? Got the Cambridge right here and so on. And I think I talked about, let's see if I have the right one here. I think I do. Yes. And it talks about, I flip mine a little more, okay? So please flip to May, June 2010, 31. All right, May, June 2010.
In the back.
31. So down, let's see here. Right here, because they're back and forth, okay? So do me a favor and this guy right here. That one right here, okay? So when you finish, okay, I'll probably have to do it all over again, all right? It's this one right here. All right, so do I have any papers here? Is that mine? That's mine. Anything else, okay? So which one do we take? So it's the May, June one. Yeah, just get your May, Junes, okay? I separate them as May, June, and the summer and the winter. Go ahead, Ems.
The reference.
Do you want to take this for reference?
Yeah.
Pardon me?
31, 32 is
What paper it's on?
yeah.
Oh, yeah. Isn't that what I said?
97. Is
970931?
Yeah,
I
I was
separate.
just letting you
Oh.
know if you didn't.
Oh, yeah, yeah.
Yeah, so 9709 is the class.
And then that's the paper 6 or something, right?
Paper
And
one.
paper 1. You guys are 1 and 7, right? That's what she was telling me. Well, I don't know. I can't remember.
1 and 2 is AICE Math 2. AICE Math
Yeah.
1 is
I have it
61,
right
62.
now. I got it. So if you take a look at this one right here, is everybody on this one? Yes?
Yes.
Yes. Has the funny semicircle and everything else? Yeah, it looks like a pizza pie, so to speak.
I remember
All right.
reading it.
Yeah. Yeah, okay. Because I want you to have your calculator out as well and then see if these approximations that I did are correct as well. Okay? Yeah. Okay? So this is just the introduction, and this brings about calculus 1 in my opinion. The derivatives and so on. Okay? So for the first, it says number 6, our first one. It says the diagram has a semicircle, right, etc., right? And then it gives this function, right? X equals something, right? 3/4 pi minus sine of x. No big deal? Everybody okay? Yeah, yeah. All right, now it says, hey, satisfy the equation, right? So you're given, this is your initial equation. I already did all this, and you're going to do one later on in a moment, if we have time, okay? So the first thing I did is I said, oh, I just started, I moved this x over, I got everything to one side, okay? So initial condition, right? Whatever they gave me, right? And they're going to put an n plus 1 and an n there, right? Okay. So how do I satisfy this equation or whatever it is, right? So the first thing I did was, I stuck an f of x somewhere. I just said f of x, y equals something. And then I just move this or move the stuff over and so on. So I made it look like, I think, this guy right here. And that should be a minus or whatever. This is a minus. I just pulled it. So it's x plus something. So I move that over. I got everything to one side. And I stuck a f of x on it. Okay? Not bad. Now I did this f prime thing. What's that mean, you smart people?
The derivative.
Derivative. What number of derivative? First, second, third, 10,000? What?
First.
First, with respect to x. So that means it's a simple basic derivative, right? Boom, I took the derivative, and they're all plus or minuses, right? So some difference. So you take the derivative of everything that you see. So the derivative of x is?
1.
Go ahead.
So where'd you get the f of x from?
I just pulled it out of the ether. So what I did is, in order for me to do it, what I did was I just said f of x equals. So I had two variables. You can actually do that in math.
And you just move the x over?
I solved everything for x. I solved everything for f of, yeah. See, it was x is one side and the other. So
Yeah.
I just got everything on the other side, and then I said it becomes 0. Then I said well, the 0 becomes f of x. It just becomes y.
Okay, so you
Okay.
moved everything that was on the right to the left.
Yeah,
Okay.
it doesn't matter, and then I changed the sign and so on. I did it at the same time. And then it should be 0, right? Minus 0. I was doing it really fast. I didn't mean to. I know there's two equals there, right? So now I take the prime, right, with respect to x, yeah? Well, that one's 1, right? N to the x, remember that? You guys have another way of doing it. She hasn't shown me yet. I'm really liking that as well. Wiggle, wiggle, right? What's the derivative of sine?
Cosine.
Cosine, right? And then the derivative of any constant, no matter what it is,
0.
even if it's this guy, right? This guy,
Yes.
you go to 0. Why? Why is a constant 0 when you take the derivative?
Because there's no x on it, so there's no exponent.
Okay, I'll live with it, all right?
Well,
Yeah.
the exponent is
X is
one.
to the 0 power.
Yeah.
So when you bring the 0 to the front, it's times 0.
Yeah, okay. Is there any change in the number? Is the number like pi, is it the same thing in pi on Jupiter as it is here? So there's no change, right?
I was going to say, because we like donuts in math.
That's right, donuts, yes.
The
That's
donut
it.
hole.
Yeah, the donut hole, right. Any constant is 0, no matter how beloved it is, even pi. And they've been only using this guy for about 200 years, the pi symbol for 314. Okay, it's another class. So now I solve this, right? Now I set this thing equal to 0, and then I move it over, right? And I got cosine x equals minus 1. Makes sense? So I have this, right? And I just set that thing equal to 0, so it's a big 0 there. That's 0 anyway, that has no consequence. So that becomes 0. Okay? Not bad? I'm looking, I'm waiting. Yeah, no, I'm totally lost. Okay? See, I'm on Wednesday mode. You know what they're thinking of moving everything to Friday? So, you know, that's like, isn't that like half day on Friday? Isn't that, yeah,
should
so
do
all
that.
the teachers would be like half doing it, right? Yeah. I'm serious, I just read it,
I thought
right?
they did already.
No, it has to be, it's tabled. Not tabled, it's, goes up to get anointed and blessed and so on, okay?
It's not even gonna affect half of us because we're all seniors.
Right, it does affect you guys, are yeah.
Mad.
I need my
So-
Wednesday, so I don't.
Cosine of x equals minus 1, you take the inverse, good old, if you didn't know that, right, you just use your calculator. I did my San Antonio Tractor Company. I know that cosine's negative in the second and third quadrant, using the unit circle. Oh, V8, right?
We're doing this again.
And then boom.
Circles back.
I'm
So voila, you got the values for x, so that answers this question. Now there'll be another one that we do a little differently, okay? But it'll be all right? Sometimes you have to show one side equals the other, all right? But I showed that you got the value to be pertinent, okay? All right, that's one down. Everybody okay on this one?
Mm-hmm.
Then we'll just put that on the, yes ma'am?
basically,
Yes.
in like layman's terms,
Layman's terms, okay.
we're making it a function
Yeah,
and then deriving it.
Yeah.
And then doing the
yeah,
circle thing.
yeah.
Okay.
Not all the time, but for this one, it's a pretty good one to do, yes.
Wait, so those x values make it so...
It
that-
satisfies it, yeah.
Yeah, well those x values, when you plug it into the derivative, makes it 0?
Yeah, it means one side equals the other side, okay? It just says, show x equals this stuff. That's all.
Okay, so we're proving that by finding x values?
Yes.
But how do we know that it's proved if we get...
You just have to, it's called satisfying the equation. In other words, does the left-hand side equal the right-hand side? Okay? Or it's like a literal equation, you know, like you have E equals MC squared solve for C.
Oh, so you're finding the value.
Something, yeah,
Like
yeah,
X, it's gonna-
yeah.
it's gonna equal each other.
correct.
Okay.
Okay? That's all they're doing. I'll do another one later. Don't worry, I know it's the early
So all
one.
you're doing is just showing that, right?
Yeah, that's what it wanted me to do, right? It said show. Okay, I showed, right? That's 3 points. Give me my 3 points. Okay?
Mm-hmm.
Not that hard.
Not bad, right? Now watch the next section. The next section's cake. It's just all
You know why
frosty in
this
the
is
works.
nifty?
Yeah.
Because it's calculus.
Yeah, it's calculus, right?
Just
Calculus.
saying.
Oh my
Yeah, from
gosh.
standing in the
I
liver,
missed
calculus.
equations so badly.
All right.
I know,
So,
right? I missed numbers.
all right, that's eyeball, right? Now double eyeball, right?
Yes.
So it says using 1.3 and 1.5, determine if there's a root. Okay, this is a biggie. Okay, this is like 2 points. If you ever miss this, don't come to Starbucks because I will be screaming at you. Okay, because it's that easy. All right, it's too easy for you. Now I know I maybe shouldn't say that, but that's all. Okay, so all I do is I plug in everywhere there's an X.
A 1.3.
Okay? A 1.3. Oh,
And same for
Seriously.
1.5.
Why 1.3, not 1.5?
because it told me. Let's do it separately. Okay.
This last
Okay, so you
One,
do both.
right, okay. This is a good question. Okay, where's mine? Oh, I lost it. It's over here. So it's, Ryan always asks me good questions. Everybody does. So here we go, right? So 1.3 is here on the number line magically, and 1.5. So when I plug in 1.3 into that said function, now I just said f of 1.3. Is that okay? So then x is right there, okay? And then I got a 3/4 pi, which is 3/4 times 3.14. And then voila, I believe you have to change that to radians.
And then it's
Okay? And then you're going to get this value right here. And so for 1.3, it comes out to be a negative value, whatever it is.
And then when you do it for 1.5, it's a positive value.
Oh,
It's a
so you
positive
know that
value.
the zero
So
is
in between is
between
not a
them.
root.
There's a root.
Oh, okay. That makes sense.
Mr. Murmer.
There's a root right there. Yes, sir.
So in order for that to be true, one has to be negative and the other has to be positive.
Or alternating. Yes, they must be alternating signs.
But it can't be positive, positive, negative, negative.
Correct. It can't be both the same signs. Why? Thank you.
How do we know when to do that?
See? All right. Sorry.
How do we know when to do that?
How do we know to do what?
The number of
But
x value.
what
that-
sign goes where?
It doesn't matter.
Okay.
Okay? If you have a difference of signs and you demonstrate it, you got the points.
Okay, so if I were to do, like, 1.5 was negative, and then.
No. You have to.
This is the
You
chart
have to get
thing.
plus or
This
minus,
is
right?
the chart thing.
You got to tell me the right sign for the corresponding value.
Okay, the way we do this
Yeah.
is, okay, so they give us the 1.3 and 1.5, and then we have the less than greater than, right?
Yeah, but
Oh,
right.
It's the chart.
It's the chart, but you know that it's between. There's something that exists inside here. Okay. There's something that exists inside here. All right.
Yeah, so the way we have to write it is with the chart, and then the chart,
Here you don't have to. I found the solutions and he didn't do it either. I'm sorry.
It could be any number of
Yeah.
things you don't answer.
Yeah, you don't know what's here. You just know one exists. You just know there's something that exists in between there. And the question said is, hey, verify. Well, I just verified it for you, right? If there's a sign change, you know there's a root that exists. That's it. And how you do it, M's and company, is well, one's negative, one's positive.
But
No.
how do you do that?
How do I know? Because I get, when I plug in my lower bound, so to speak, I get a negative.
I didn't see that.
That's okay. I know it's hard to see. I didn't have enough time because I lost my zero period because we were doing panic things. You know, safety stuff. Okay. All right. You know, Quinlan, right? Mr. Quinlan. So he drug us. He didn't drag us. He's cool. He just made us go outside and go, oh, we're at the basketball or pools. I had to go to another area, right? In 3 years, I've been to 3 different places. So I'm like, I don't know where to go. So I have to, like, you know, like a little puppy dog.
Mr. Quinlan drug you?
Yeah, no, he couldn't. Trust me, he wouldn't. And he couldn't either. All right.
Nick!
We
So-
talked about Xanax yesterday.
Yeah, I was on Xanax. So
This
here's
is
a
on
positive,
video.
here's a negative.
So
All right.
that's video.
What- Take home message, different signs, you know there's a root, you verified it. All right? Not bad? All right, so that was, this was 2 pesos, this is 3 pesos, this is 2 pesos, right? I just like saying pesos. I lived in Mexico. I lived everywhere. Iterative.
It's more of a sound.
Of course it is.
Pesos.
Yo pesos.
When we
Yeah.
have an equality.
All right, so any questions here? Remember, some silence or partial silence means one of two things: total confusion or total complete understanding to the point of nirvana. I'm going to take choice B. All right? I'm going to take choice B.
Because you do it differently than Miss K does.
It doesn't matter. But I did it the way that I saw. Yes, go ahead.
If we have to solve, would we use the chart? Because this is technically just saying.
Well, see, the way
You have to verify by using the function, though.
okay, the
You
only
have to
difference
verify.
between the chart and this is that they give us the stuff that we're supposed to plug in.
Well, they
Because
gave
with
you-
the chart,
Use the chart to give us the value.
Right.
yeah, there's no, yeah, but it's the same.
Well, look what they gave you, right? You don't. You can't.
Greater than less than stuff.
Okay, hold on. You can't. I agree that if you want to, in a pinch, use the chart that tells you. But then you have to, in order to grab those points, right? Evil Cambridge person is going to grade this, right? So that means you got to do verify. I verified that those exist.
Yeah.
Okay? It's a loaded question because you know it exists. Because why would they ask anyway? Okay?
They're just testing to see if you can figure it out.
Thank you.
You can prove it, really.
Yes, even better. I love the word prove or prove it. Okay?
So what's part 3 now?
All right, triple I. Okay, you ready? Door number 3, right, for Monty Hall, right? All right. So, okay, it says here, the additive thing, it's 3 pesos, right? Pesos. All right.
Tres pesos.
That's it. Notice it said x to the n plus 1 equals this constant minus sine of x to the n. Okay? No big deal. It gave you an initial value, didn't it? Yes, it did. It says it gave you what? The lower value, which was 1.3. Okay? Okay? And it says, let's see if I'm reading it correctly, which I am. Yes, I am. So, x of 1 is 1.3, which I put right here. You substituted into this initial equation. All right? I know it looks really strange. Everything's always strange when you first see it. So, this is x to the... In order to get the second one, I start off with the first one. Yes? The first one was what?
1.3.
What was it again?
1.3.
Well, what?
1.3.
Thank you. That's what you start with. So that's x1. Every time x1, the subscript, you add 1 to it to get the next value. So we're figuring out x2 from x1. Yes? So that means 3/4 pi. Well, that doesn't change. And that's 1 plus 1, which is x2, minus sine of 1.3. Yes. Everybody okay?
3/4. You got.
3/4 pi,
Mm-hmm.
and then change it to radians. Okay? You with me? Me too. Okay.
And we know it's radians because you see pies.
Yeah, very good. Very good. Remember pi's 3 1/4, right? 3.141592653 rate stop. But you get the idea.
9, 3, 2, 3, 8,
Yes, that's the next strand. Good. Okay. When you plug this one in to get x2, right? You get this value. You take this value and you do it again, which is x3, then x4, x5. Yeah, hold on. Go ahead.
Alright, so why is it 1.3 as opposed to 1.5?
I know. Okay. You always take the lower of the roots. Okay. You always take the lowest
The
bound.
lower bound.
The lower bound. Unless they give you something else, right? They could have said 1.7. So whatever, because there'll be another one in here, I think. They're going to give you the value, okay? And we'll go through one of them. They just go, well, x1 is this. Go and do it, okay?
Okay, so they give you like.
Sometimes they give you the value.
Mr. Murmer.
Go ahead. Yes.
So how do you know when to stop doing?
Oh, this is a great question. So you go indefinitely, right?
You don't. The trick is you keep going and eventually you die.
You don't.
Melody.
So it wants you to go by 4 places. Every value you get, it says to go to 4 places, right? All right. 1, 2, 3, 4 after the decimal, right? Etc., etc., etc. Now I went to 6. You could have stopped at 4 if you want, right? You could have stopped at x4.
So why did you go to 6?
I just felt like it. Okay. I just wanted to show by more exhaustive method of doing it, to show you that it's going to converge at these points. Okay?
I didn't get 1.3926.
You didn't get 1.3926. With radians? Really? Okay. I did, but I'll see what happened.
Oh wait, I see what I did wrong.
Okay, all right.
How?
So it says, okay, you got all these, right? I'm going to just list the answers, the stuff here, okay? You had 1.3, right? The next one was 1.3926. Don't count the first value, yes? Next one, 1.3759. Next one, 1.3751, etc. 1.3753. Round this to 2 decimal places. What do you get?
You mean like?
Yeah, what's the best guess here?
1.39.
So best one, right? So 1 point, we know it's a 3. What do you think? Just
8.
8 is the best one. That's what they want.
And that's the root?
That's the approximation that they used.
Approximate root.
Yes, ma'am.
And we did
It's the
it
root.
4 times.
I did it 4 times. You can go. They like you do at least 4 times. I've been looking at all the solutions as well, and they go like 4 or 5 times. Okay.
So you do it 4 times, then you like.
And then you make a judgment call. 2 decimal places. Your normal rounding rules. Nick,
So how do you determine which one to use?
how do you always use the lower bound? Okay.
No, but
Oh.
like the answers.
Oh, you mean for
3.926.
here?
Yeah, all that.
Because I generated it, right?
How do you know which one to pick for the answer?
You use all of them?
I just compared these, right?
Guesstimate.
This is x2, x3, x4, x5,
You'll
x6, or
round them
whatever.
all
Right?
to like 2 decimal places, and then you're gonna see one pop up more than the other. Like you
Right.
get a
Yeah, you're going to see a recurrence of values.
9, and then the next.
Yeah,
one
1 point, then, 7, 7, 5, 5, and it's going to be like 5, 5, 3, or 5, 2, 7. You know what I mean? It's going to keep on converging. It's going to, you see, it's going 5, 9, 5, 1, 5, 3. Well, most
Yeah.
likely it's going to do the same thing again. It's going to start hitting that value again and again. Okay? Because if you think about it, you have the golden ratio, right? Let's say you have, what's Fibonacci? Remember Fibonacci? 1, 1, 2, 3, 5, 8. So if I took, let's call that f of 1, f of 2, f of 3, right? So if I took the ratio of f of 3 over f of 2, right? Let me see if I'm doing this right. Yeah, 3 over 2, I get 1/2, right? Now if I did 3, 4 over 5, or 5, yeah, 4 over 5, f of 4 over 5, I get 5 over 3, I get 1.66, okay? Everybody knows that the ratio of Fibonacci is 5, right? 1.61, 4, 3, etc., etc. But look, it's 1.5, 1.66, yeah? So if I did, what? The next one is 8 5 is 13, right? Someone tell me what 13 over 8 is, please.
Something.
I already know it anyway, but tell me.
1.625.
1.625. You see what's happening? All right, how about 21 divided by 13?
1.61538.
Yeah. You see it? It's starting to converge. You see it? It's starting to become more and more iterative at that value. Okay? So this is just boom. Phi is always, we use that anyway. The golden ratio, the golden rectangle, and so on. All right?
If you're a mathematician, how many times do they usually iterate?
Ooh, great question. Am I working for NASA or am I working for myself?
NASA.
I'm working for NASA. Everything's calculated to 9 digits after the integer.
If you're working for yourself,
3.
I do it by exhaustion. X of infinity. I can show you how to
just
do
keep
that.
going until you like.
I do like at least 200 of them,
Do it.
and then I.
Let's go.
That takes too
My
long.
calculator doesn't
Yes,
do that.
yes, Ms. Aber.
So 1.3 is the answer.
Yes, ma'am. That's it.
So
This would be 3 pesos, right? Pesos. Okay. Okay.
The
Show
III.
your points. Triple I is 3 pesos, or us Americans say pesos. All right. Any questions?
Have you seen a situation where we have to create an iterator formula?
All the time. I can do that. It's the beginning of calculus. Yes. What you're doing, how much time left, guys?
not enough.
Not enough.
3 minutes.
What you're really doing is if you had, let's say, a hyperbola, right? Hyperbola. And what you're trying to do is find the best fit associated with the first derivative of that thing. And the infinitesimal points that are associated with the first derivative and the function. That's what you're doing. Okay, yes.
So plugging that into iteration, if we have to do the problem again, is it reiteration?
Repeat iteration, yes. All right, we'll do one more tomorrow. I'll let you guys fiddle with it and so on, mitigate it, I guess. All right, not bad. It's just plugging the excessive points in over and over again. And in the remember she had on there, I forgot her name, the actress, but Dr. Johnson there, she had this value next to it, 1.6709. Just yeah, it was 1.6709. That was the iterative that she got from the equation she used using Euler's method. I might show you a video on that, and maybe we'll do the square root of 2. When I was in calculus, when I was like very young, 1,000 years ago, they would say